2, 1. Welcome everyone. Today I will present our project on real-time face AI and mouth detection using the hair cascade algorithm. Actually, this project is significant due to its application in monitoring mask completions, especially in the context of the COVID-19 pandemic. Our main goals are to detect masks and identify key facial features. And the here cascade algorithm proposed by Viola and Jones is a machine learning based approach for object detection. It uses here features which are contrast based rectangular features and integral images for fast feature calculation. ADA boost is used to combine weak classifiers into a strong classifier, and a cascade of classifiers ensures efficient detection. And also we start by loading the pre-trained here cascade classifiers provided by OpenCV. These classifiers are stored in the XML files and are used to detect faces, eyes, and mouths in images. Here is the sample code snippet showing how we load these classifiers, as you can see. Okay, now we capture frames from the webcam using OpenCV's video capture function. The captured images are then converted to grayscale. Grayscale image simplify the processing and reduce computational load, as we only need to work with in intensity values. Now time to detecting faces. Now we apply the face classifier to the grayscale image to detect faces. Detect multiscale function is used to find faces at different scales. Detected faces are marked with rectangles for visualization. This step is crucial for further detection of eyes and mouth within the face regions. And then after we found the face by rectangles, time to detecting eyes. The eye classifiers applied within these regions using detect multiscale. Detected eyes are highlighted with rectangles again. This helps in ensuring the accuracy of mask detection by checking for eye visibility. It's same again to find the mouth. The mouth classifiers applied to the lower portion of the face. Detected mouths are marked with rectangles again. Detecting the mouth is vital for verifying the mask completions. And also, to simplify, by combining face, eye, and mouth detection steps, we achieve real-time detection, and the results are displayed with visual indicators showing whether a mask is worn correctly. This provides immediate feedback to the user. Thanks for listening to me.
First, we load an image called virus with this line, and we convert the loaded image to a grayscale image. This is because grayscale images are easier to process to create binary image. Now, we came to applying threshold part. Here we create a binary mask applying a thresholding operation to the grayscale image. The threshold is set to 10, and all pixels above the threshold are set to 255, and all pixels below the threshold are set to black. Why we do that? Because by loading the image, converting it to grayscale, and applying a binary threshold, we prepare a mask that can be used to identify and manipulate specific regions of the image. These sets are essential for creating a system that can accurately detect and process mask wearing in a video frame. The grayscale conversion simplifies the image, making it easier and the faster process, and the thresholding operation isolates the regions of interest by converting them into the binary format. Let's look at the other part. If mask wearing. First, we resize the mask to the mesh dimension of the face. The virus resize and mask resize. Variables resize the mask image and the binary mask respectively. Then we invert the binary mask. This is used to mask the background of the face image with this line. We make background of the face black where it overlaps with the inverted mask and applies the mask to the part of the face that should be wearing a mask. Then we invert the background and foreground so that the mask is properly placed on the face. And finally, we overlay the final image on the original video frame. But it's not over. If the user is not wearing a mask following line, in this case, check mark is shown a 13 frame section and the message wearing a mask is printed. In this way, we have created a system that checks whether the user wearing a mask or not.
Now I will continue with my part. I will talk about half transform. OpenCV uses half transform for image processing. Now with input image, as you can see, OpenCV draws line on object and add points on that lines and finds slabs of all dots and transform them to the angle radius graph and draw something like this, as you can see on half transform part. This is the main logic of OpenCV. Now let's continue with our codes. Now first we have three parameters here. They're gonna be used here. We have a getIGray method here. We have circles of it with these parameters and we assign it to the circles. And if circle is not none, the code will continue. We have ABR parameters here that are gonna be used here. We circle getIGray with its color. I maybe create a circle here with these coordinates. And now here we removed iris and purple together. We found purple, pupil, and we have circles IFG gray here. And assign to new circle. If new circle is not none, the code will continue. We have again something similar at above. Three parameters we have here, and we're gonna circle IFG gray with those parameters with same color. And we have mask. We threshold IFG gray to create a mask, and we bitwise the mask and I on INIV FG to find the NIV FG color. And this is the shape of our NIV FG. This is the mean color of INIV FG. This is again an OpenCV method. We have frame of my eye, and we have frame of INIV FG. We found colors of eyes, and we have three parameters. They are the Irish mean colors, 1, 0, 2. Eye color is gonna be, and we have eye color frame. Lastly, we identify the eye color by these if and ellipse. And this is the end of our code.
Hello, let's continue with the menu section, which is the main in here. Firstly, we create a create menu function, and these are just show this info of main menu. In here, first we create the title and its matrix, which is 438, 308, and in here we import the menu image and we create labels. But first we create the frames, which is we're gonna show. It means here is the main frame, here is the info frame. Let's close, and we create some labels and it paddings. PD means paddings. That's all, and we create pull it. And on the bottom of the program, in here we create a profiler because this is the eye detection and the mask detection, which are with so many metrics we are doing. So we have to analyze the program's function, this part provider, and continue with this program. In here we create an empty metric space, which is the which size is the frames I exist and frames X exist plus 100, because we're gonna show a eye detection place. This 100 comes from here, and we say it's gonna be 3-dimension, and the 3 dimensions parts are gonna be between 0 and 256, which is the color space. We identify that, and we clear the free space of this matrix with this white. We paint it in here, and we create a eye color matrix, which is the same thing. And here we add the text, which is this is the y-axis, this is the x-axis. Sorry, this is the, but in here this is the x-axis, this is the y-axis. It's different with the that. In here, this is the y-axis, this is the x-axis. In here, this is y, this is x. Let's continue with my part, which is in here we check the mask wearing. If we have mask wear, it's gonna be false, and so it means we can't use the eye detection with the wearing mask. Without the wearing mask. And in here we get the circle of the eye, and firstly we paint it with the black, with the include of this, not around it. We paint it all, and in here we use a threshold, which is if the color of this gray matrix point is bigger than 10, it's gonna be this number, but if it's less than 10, it's gonna be 0. So we create a mask with that, and we multiply it with 0 and 255. It's just like a 0 and 1. So we get I from the end, and we get the gray, and we detect new circle, half circle, and in here we get the, as you see, with the same logic, we get the circle, and we paint black with the, and in here we get the eyes, y-axis shape 0, and to implement it to the or main sequence. Hello, let's continue with the demo section. Start the program, and in here we can see the features of our program OCQ, and we have to wear mask while using the eye detect. Let's continue with the start this program, but I have to close this camera, and let's continue with start. Now, as you see, it detects my face, and it can't detect any mask. It means it can't detect any mount. So it says there's a people who doesn't wear a mask. Let's wear our mask. And as you see, it says the user wear mask. Let's continue with eye detect. In here, I need to use flash, and I'm gonna find this eye. Now, as you see, it found the eye, and it says this here, and the iris like in here. So it's close the iris, close the iris, and it detects the general eye color, which is the in here present, and it says this color is brown. So if I press Q, it closes the program, and if I press close, I can see all of the function in here to use. Thanks for watching us. Have a good day.